సబ్స్క్రైబ్ చేయండి. ఫర్ మోర్ అప్డేట్స్ బెల్ ఐకాన్ క్లిక్ చేయండి. ప్లీజ్ లైక్ అండ్ షేర్ చేసి కామెంట్ చేయండి.
CE characteristics of BJT. CE means common emitter. CE full form is the common emitter. Common emitter means emitter is the common to base and collector. Base and collector. Characteristics means drawn the graph. BJT means already we know that BJT is nothing but the transistor, that is the bipolar junction transistor. Bipolar junction transistor. So CE characteristics of BJT means common emitter characteristics of BJT. Here BJT taken as a NPN transistor. So this is the emitter. This emitter is the common of this base and this collector. This is the collector, this is the emitter, this is the base. This emitter is common as the base and collector. So this is the common emitter configuration. Common emitter configuration. Now we discuss the CE configuration characteristics. So this is the base emitter junction. This is the base emitter junction. The base emitter junction is always in forward bias. Is always in forward bias. So forward bias means this is the NPN transistor. This is the NPN transistor. This is the P. This is the N. This is the N. Okay, this is the NPN transistor. So the P type of semiconductor is connected with the positive terminal of the battery. This is the positive terminal. N type of semiconductor is connected with the negative terminal of the battery. So this is the battery. Base battery. This is the base battery. So this is the voltage across the base and emitter junction. So here we connected with the voltmeter. This is the voltage across base and emitter. Now here we connected with the ammeter. So this is the current into base. This is the ammeter. This is the voltmeter. So this is the forward bias. This is the forward bias. Next, this is the N type of semiconductor. This is the N type of semiconductor. This is the collector and emitter junction. This is the, so this N type of semiconductor is connected with the positive terminal of the battery. This N type of semiconductor is connected with the positive terminal of the battery. This N type of semiconductor is connected with the negative terminal of the battery. So this is the collector battery. So this is the voltage across between collector and emitter. So This is connected with the voltmeter VCE. Here we connected with the ammeter. This is the current into collector. This is the I collector, current collector. This is the base collector. This is the emitter collector. Emitter current. Emitter current. This is the circuit diagram of the characteristics of NPN. There is another circuit diagram. So here same circuit we connected with the resistance, forward resistance and reverse resistance, and input resistance and output resistance. Same diagram. This is also circuit diagram. This is the resistance. This is the ammeter. Same diagram. This is the ammeter. So this is the R1 resistance, this is the R2 resistance, this is the input resistance, this is the output resistance, and also same as this is the forward resistance, this is the reverse resistance. This is the total circuit diagram of the CE characteristics of the BJT or transistor. Now we want to measure the potential difference in this circuit, forward circuit. We apply the voltage. And changes the current into base. So we apply the voltage, changes the current. Now we draw the graph with voltage and current, that is known as the forward characteristics or input characteristics. Same as we apply the voltage between collector and emitter, that changes the collector current. Now we draw the voltage and current, that is known as the reverse characteristics or output characteristics. Thus the way there are two types of characteristics of the BJT or transistor. One is the forward characteristics or input characteristics. Second one is the reverse characteristics or output characteristics. From Kirchhoff's law, the current entering into transistor through the base, the current entering the transistor through the collector, this is the current leaving from transistor through the emitter. So from Kirchhoff's law, entering current is equals to leaving current. Entering current is the base current plus collector current is equals to emitter current. So emitter current is equals to the sum of the current of base and current of collector. Now we draw the characteristics of the BJT or transistor. One is the forward characteristics. Forward characteristics is the drawn the graph between voltage and current. Reverse characteristics of BJT, that is known as the output characteristics, drawn the graph between voltage, this voltage, and this current. Okay, now we have to draw the operational circuit. This is the NPN transistor, this is the base, this is the emitter, this is the collector. Okay, this emitter is common to the base, this is the base, common to the base, this emitter common to the collector. Okay, so this is the emitter base junction, this is the emitter base junction. Emitter base junction is always connected with the forward bias. Forward bias means P type of semiconductor is connected with the positive terminal of the battery, N type of semiconductor is connected with the negative terminal of the battery. So this is the reverse. So this is the N type of semiconductor is connected with the positive terminal of the battery, this is the negative. Okay, this is the emitter, this is the emitter. Emitter is common to base, emitter is common to collector. So this is the P type of semiconductor. In the P type of semiconductor, majority charge carriers are holes, minority charge carriers are electrons. N type of semiconductor, majority charge carriers are electrons, minority charge carriers are holes. Same in N type of semiconductor, majority charge carriers are electrons, minority charge carriers are holes. First characteristics is the forward bias. Forward bias, that means forward characteristics. Now we connected the battery. This battery is the base battery. Base battery. We apply the voltage. So voltage between base and emitter changes the base current. So voltage 0, 0.1, 0.2, 0.3 and 0.4, 0.5 and so on. So the base current is changes 0, 0, 0, 0.01, this like 0.02, 0.03, this like changes. Okay, because here this is the positive terminal, so this is the positive terminal, this is the negative terminal, this is the negative terminal. So this positive is the repulsive, this negative is the repulsive. So the voltage and current are changes with this type, 0 from 0, 0.1 to 0, 0.2 to 0. So now we draw the characteristics, the graph. This is the x-axis, this is the y-axis, this is the current IB, this is the voltage V, this is the 0, 0.1, 0.2, 0.3, 0.4, 0.5. Current is the 0.01, 0.02, 0.03, 0.04, 0.04. At the 0 is the 0. 0.1 is the current is also 0. 0. Is the current is also 0. 0.3 current is the 0.1. 0.4 current is the 0.2, 0.5 current is the 0.3. So the curve is just like this. This is the forward characteristics. This is the forward characteristic or input characteristic. At this the current is no changes, that is the 0. This is the cutting voltage. From this point to current is increases. From this point to current increases proportional to current. From this point to current is increases. So this is the input characteristic. This is the input characteristic. We draw the slope. This is the change in IB, that means delta IB. This is the change in delta VB. So the ratio between these two input resistance, so that resistance is R1, input resistance is equals to change in voltage between base and emitter, change in current base. This is the input characteristic region, this is the output characteristic region, this is the forward region, this is the reverse region. So in input characteristic or forward characteristic, the input resistance is the ratio between the change in voltage BE and change in base current. At this time this is the constant. At this time this is the constant. If this is the constant, the changes of voltage in BE changing the current base. So this is the ratio. This ratio is known as the input resistance. At this time this is the constant. This is the constant. So the graph is input characteristic, this is the base current, this is the base emitter voltage, this is the graph, this is the graph. The slope is represents the input resistance. At this input resistance this is the constant, this is the constant. Now output characteristics are reverse characteristics. In reverse characteristics we draw the graph between voltage collector emitter and current collector current. So we draw the graph, the values. This is the voltage between collector and emitter, this is the collector current. At this time the base current is parameter. Okay, so the base current is changes the total this value and this value, because this is the common emitter, this is the emitter, this is the current collector, this is the base. So this is the reverse connection, this is the reverse connection, this is the N, this is the P. So this is the connected with N type of semiconductor is connected with the positive terminal of the battery, this is the negative terminal of the battery. In this N region the majority charge, the minority charge carriers are holes, majority charge carriers are free electrons. In the same, majority charge carriers are electrons, minority charge carriers are holes. So this is the p region. The majority charge carriers are holes, minority charge carriers are electrons. At this time two depletion layers. So this is the one junction, this is the one junction, this is the n type of semiconductor. N type of semiconductor is connected with the positive terminal of the battery. This positive terminal of the battery and n type of semiconductor or attraction. So at this attraction the depletion layer is increases here. The depletion layer is increases here. So it's not allow the flow of current. So at this time so the this is the negative terminal of the battery, this is the n type of semiconductor, this is the repulsive. So the depletion layer is the narrow. So at this time the minority charge carriers allows the jump this region to this region. So the values are here: 0 volts, 1 volts, 2 volts, 3 volts, 4 volts, 5 volts, 6 volts. So at the time of 0 volts the collector current is the 0. So at the time of voltage the collector current is the 1. At the time of 2, at the time of 3 is the 3, at the time of 4 is the 3, at the time of S the 3 is the 3. Because so we connected the voltmeter at the 0 volts there is no current. At 1 volts the minority charge carrier is the hole. This hole jumped into this region. So at the 1 volt the current is the 1. So at the 2 volts here 2 minority charge carriers are jumped. At 3 volts 3 minority charge carriers are jumped. At 4 volts these 3 are jumped. At 5 volts these 3 are jumped. At 6 volts these 3 are jumped. So at 3 is the 3, at 4 volts is the 3, at 5 volts is the 3, at 6 volt is the 3. Now we draw the graph. This is the collector current, this is the collector emitter voltage. This is the 0, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. At 0 volts is the 0, at 1 volts is the 1, at 2 volts is the 2, at 3 volts is the 3, at 4 volts is the 3, at 5 volts is the 3, at 6 volt is the 3. So this is the one, this is the characteristic, this is the curve. At some IB current, IB current means base current. At some base current is this characteristic. At base current some values changes. At some values change. Next characteristics, next curve is this type, next curve is this type, next curve is this type. So at IB changes this curve, at IB changes this curve, at IB this changes curve. So IB changes total these values. So this is the output characteristic or reverse characteristics. In reverse characteristic or input output resistance is the same. The ratio, the change in voltage between collector and emitter, the change in current, collector current. At this time, IB is constant. So input resistance is the ratio change in voltage base emitter and change in current base. At this time, VC is constant. At output resistance, change in voltage collector and emitter, change in collector current. At this time, IB is constant. Totally, these are characteristics of BJT.